of your, and now it should be all. The floor is yours, Marcel.
Okay, thank you, Sebastian. Thank you. I hope you can hear me good. Yes, I am Marcel, and I am the one responsible for CBM TapePi, which is a mass storage solution for Commodore 8-bit machines, yes, from the 1980s and from the late 1970s. Maybe you heard of them. And it uses a Raspberry Pi. You can see it here. I hope you can see it here. And the currently supported machines are the C64 and the VIC-20. This model is especially ugly, but it has the pad keys. And the pad series.
Sorry, but I don't. We see your video, but we
you don't see my video.
No, I don't think that you're sharing something.
Okay.
So
I'm sorry. This was my fault.
We can see you, but not.
Thanks for the hint. Can you see my screen now?
Yes, now we can see your screen. Yeah.
That's fine. Okay, let me restart. Okay. You heard me, so you know already I'm Marcel, and I created CBM TapePi. This is the picture you could not see before. This is a Raspberry Pi that CBM TapePi uses, and the little interfacing circuit. I will switch to full screen again. There's the Raspberry Pi, and currently supported is the C64 and the VIC-20, and this is the ugly one I was talking about. And the PAD series of computers, PAD 2001, 3032, 4032, 8032, these kind of machines are currently supported. And CBM TapePi makes it possible to load from an SD card and to write to an SD card directly from the Commodore computer. This is nothing new. There's at least one option out there for these machines that makes it possible to use modern storage devices like SD cards. Here are some examples you may heard of. So why CBM TapePi? Let me answer that question first from my perspective. I wanted something to be able to send my cross-developed PRG files directly to the pad in a fast way. You can use an audio tape adapter to do this and connect it to the sound card, but I was looking for something better. And I like creating something that is closer to the hardware than what I'm doing in my daytime job. I'm working as a software developer and mostly with C# and JavaScript, and that's so far away from the hardware. I learned bare metal C because the CBM TapePi is a bare metal application, meaning it doesn't use any operating system on the Raspberry Pi like Linux or something. And I could improve my 6502 assembler programming skills and my Commodore knowledge. Yes, and I even got to create a little hardware thing, the small circuit that is interfacing the Raspberry Pi with the CBM computer, the Commodore computers. And I also hope there are some reasons for you to try it, maybe build it and check it out. It's a cheap solution. The parts are all readily available and it is easy to build and set up. And it just occupies the dataset port of your computer. It has a high compatibility and it's fast and it's open source. Yeah, about the parts and the costs and availability. What do you need? You need a Raspberry Pi. Maybe you have one lying around in a desk drawer waiting for a project to happen. You only need a Raspberry Pi 1 or 2 or a 0, and you can also take a Raspberry Pi 3. Then you need that simple interfacing circuit you see at the bottom left image. It uses discrete components only, only transistors and resistors and one LED. And yeah, and that makes it possible. You don't need to order something from a foreign country. You don't have to pay taxes. There's no long waits. Yeah, these are the advantages. I hope for you to try it out. About building CBM TapePi, as I said, It only needs a dataset port, and everything else is available for other peripherals, for your floppy disk drive, for example. So you need to, if you want to use the breadboard solution, and you are absolutely not into soldering, you are getting away with just soldering these 5 wires. And you can see at the top right image to the dataset port plug. And you see my soldering skills are not that good either. The breadboard solution is not that error prone, but sometimes the connections are loose. You have to take some cable out and put it in again. And if you want something even lesser error prone, you should solder it all on a strip board, or you can even use a PCB. Sven Petersen, you may have heard of him. He does a lot of stuff for the community, has a lot of hardware projects going on. He made a layout for a PCB and he sent one to me. Let me show you the breadboard solution first. And as you can see, in German, we call this Kabelsalat, which means cable salad or a lot of tangled wires. And if you're replacing this with a PCB from Sven, it looks like this with a Raspberry Pi 1. You see the Raspberry Pi, and on the other side, the PCB is connected to the CBM computer. Already lesser cables, but you can go further and use a Raspberry Pi 0. And at the right image, you see the VIC-20 and the CBM tape by PCB connected, and there are almost no wires. By the way, on the right image, at the top, you can see a hyper expander. That is also something Sven Petersen built. Great stuff. Okay, about the compatibility, I already told you it is compatible with the C64, the VIC-20, and the PET series of computers. And if you know the PET computers, you already know there are 3 basic versions, version 4 and 2 and 1. And all 3 are supported by CBM TAPI. CBM TAPI has 2 operation modes. There is the compatibility mode and the fast mode. And the compatibility mode, it works out of the box, if you will call it that, because there's no extra software on the Commodore needed. It just uses the kernel functions. The fast mode, it needs a PRG file to be installed first. And the compatibility mode, it is controlled via the normal save and load commands you already know from your floppy disk drive or your data set. And the fast mode is controlled via the extra commands. You have to install the wedge for the wedge PRG file. The compatibility mode has the big disadvantage, or one disadvantage, that it is just as slow as the real data set. And the fast mode its speed is approximately 2.5 kilobytes per second. That's faster than the normal data set and faster than the 1541 on the C64, but there's still room for improvement. It is possible to do this even faster. Yes, I have not tested that, but the compatibility mode may work with the C16 and its TAP-based brothers too. Maybe it works. But for the fast mode, I definitely have to develop something special for the C16 and these kind of machines. Here's an example. You may know this screen. It's not a blue screen from Windows. These are the compatibility mode commands you can use. For example, the first one, if you want to load a PRG file from the SD card, you use save, enter the file name, and directly after that, the load command. You have to use save to send instructions to the Raspberry Pi, because the load command doesn't transfer any data to the dataset. And in this compatibility mode, the Raspberry Pi just emulates the dataset. So there's nothing special going on. So you have to use save to transfer the my CBM app.prg as file name to the Raspberry Pi. If you want to save something, it looks almost the same. You just add a plus sign as prefix and forget the load. This next command is for changing the current directory to a subfolder. Or if you want to show the directory content, you use this one. And this is probably, the last one is probably the only command you want to use in compatibility mode, because this is the command to toggle to fast mode, to one of the fast modes. Because CBM tape is made for different devices, C64, VIC-20, and so on. There are different PRG files, different fast mode types. And if you want to set up the device one time, you need to do it once, and then it will remember that you want to use the fast mode. And if you want to do that, you can select options so that it works for your machine. For example, on the pad, you have to select the basic version, which is installed on your machine. And you can choose, if you want to install the wedge, the command extensions into the tape buffers. Those are adjacent in the RAM on these pad machines, or you can install it to TOM, to the top of basic memory. On the VIC-20, it always installs to the top of basic memory. On the C64, you can select if you want it in the top of basic, or if you want to install it at the top of free high memory directly before $D000. Okay, if you did this one time in compatibility mode, you can restart the Raspberry Pi and the Commodore computer, and it will always start by emulating an endless tape. And if you are entering, is there some question, or what was that background noise? Just noise.
This was background noise.
All right. Okay. Okay. And if you're in this fast mode, you enter load on the Commodore machine, and it will retrieve the PRG file with the command extension from the Pi. And if you're entering run, sometimes this depends on the type of fast loader you're using, you want to load, then it will install the command extensions for the fast mode, and it tells the Raspberry Pi to lastly toggle into fast mode, toggle to the fast mode protocol and stop the endless tape emulation. And then you have reached fast mode. Okay, let me show you again the screen from the compatibility mode. Here are still the save and load commands from the operating system of the Commodore. The commands are, yes, they are the same, but you don't no longer need save and load, but you're just using the exclamation mark for the wedge commands. I will go back one more time. These are the compatibility mode, how you handle it in compatibility mode, and this is in fast mode. You know this from other solutions, I guess. This is for loading a PRG from SD card. This is also for saving, changing the folder, the current working directory, entering the listing the directory content, and you can toggle the mode in fast mode too. For example, if you want to go back to compatibility mode for some reason, or if you want to select another fast mode to let the wedge be installed in some other area of RAM. The future of CBM tape Pi. I have some ideas. There are ideas for small enhancements. For example, currently there is a file name limit the file name limit is 8 characters, a maximum of 8 characters for the name and 3 for the extension. You know that. You know about these kind of things. It would be cool if the directory listing command wouldn't overwrite anything in RAM, and if it would show the addresses and sizes of the PRGs, which it doesn't do currently. And I would love to increase the loading speed some more for the wedge PRGs, for the command extensions, by making them smaller. There's still room for improvement there. And some commands should show a response. For example, if you are deleting files, this is also possible. Currently, there's just the LED, and if some error occurs, the Raspberry Pi's LED, it flashes just like a 1541 when some error occurs. and many more small enhancements, but I want to tell you about two other things and two ports I'm working on. The one port is to the ESP8266. This is a microcontroller that is very cheap and it has Wi-Fi on board. I'm sure a lot of you have heard of it. And you can use Arduino to develop for it. And I'm using Platform IO for the port. And the next step there is to test the load in compatibility mode. And you have to build an SD card reader for it. Yes, there is no SD card on the microcontroller, but you can solder one directly to the pins if you want. Okay, and this is my current test setup. The breadboards again. And the good thing, as I said, is this thing has Wi-Fi, and Wi-Fi is super simple to use. And if you have Wi-Fi, you have internet, and internet, you know, this leads to world domination. Okay, and the other one is the Raspbian Linux port. I told you CBM TapePi is a bare metal application currently, and one reason for that is the scheduler of Linux. Linux is an operating system, a multitasking operating system, and the scheduler all the time it interrupts the processes. And at least when you are in fast mode and you initially want to send the wedge PRG file to the Commodore, you have to emulate the dataset protocol, the normal protocol, and this needs exact timing, and that is broken because of the scheduler. One solution is using direct memory access, and one first test was successful. I was using the library PyGPIO for it with a very small PRG file. But unfortunately, you need a lot of RAM already for the PRG wedge files. You already need a lot of RAM on the Raspberry Pi, and it seems it is not possible with this library. So I am implementing my own DMA stuff. And the next step there is also to test a load in compatibility mode. And after that, you know what comes after that. You have Wi-Fi and all the cool stuff Linux can do. And Wi-Fi leads to internet, and internet leads to world domination. Again, okay. If you're interested, I hope maybe you want to try it out. Or if you want to read something more about it, the source code and the documentation, it's all at the GitHub page. And thank you very much for listening.
Thanks a lot, Marcel, actually, for coming and presenting. I'm pretty sure I see from the comments a lot of people are interested. So I think
that's cool.
You will see some downloads in the coming days. So let us look at the questions here. Okay, this is very innovative use for dataset. Are these hats for Raspberry Pi Zero for sale? So I suppose that refers to the little
yes, the hats. Yes, I guess they are not for sale. I did not create the layout, as I said, but they are on GitHub. I can provide the link.
Yeah, that would be nice if you can also post it maybe here somewhere, or is it also on the web page that you?
Yes, it's also. I also have the link on my page. Yes, on the GitHub page. Then
with regard to the ESP8266, there are some comments that you could also use the ESP32. Indeed, that's I think it's the bigger brother of the.
That's right. That's right.
Of the 8266. That's comments about muting and muting, but I saw questions on Facebook as well. Is the version used in presentation already available for download? That's one.
Yes, it is. It is available for download. Yes.
Perfect. And then in fast mode, how is communication achieved? Similar protocol as tape card?
No, it's not similar. It's different. It's I think tape card is even faster. My protocol, there's still room for improvement. The speed could be higher, but I'm currently keeping it as it is because for the Raspbian Linux port, yes, it maybe act different because of the scheduler and yeah.
Okay, I see more. Is there more? No, I don't think. I see no more question, but maybe I had still one because you mentioned indeed, so Raspberry, so 0, 1, 2, 3, I suppose that should work with the 4 as well. With the 4, actually, you have even.
I don't know. I haven't tested it with the 4.
You haven't tested. Okay.
I haven't tested it with the 4.
And about the distribution, indeed, so you were talking about the different distribution, and in the future, the one that you plan to use then is Raspbian. You haven't tried with other more minimalistic, like maybe FreeBSD or something like that would also run on the Pi.
No, I haven't, and I think the problem is the same. Yes, so they are all multitasking operating systems, and yes, currently I'm trying it with Raspbian. And I don't know what the future brings.
Okay, no, that's usually the most simple to test as well, is to start with Raspbian because it's built for the platform. I would say thanks a lot, Marcel. If there are
thanks for having me.
More questions coming in, maybe they can be posted in the chat. I will stop the recording now. Thanks again.